Hey guys, this is Pete from MyJewelryBunch.com. Today we're going to work on this cheap knockoff Chinese Breitling imitation watch. Customer really likes this watch and I can get it running. It's not a problem. The movement wasn't working very well. We got it kind of running up a little bit, so I'm not too worried about getting this watch running. The issue is he took this to a flea market repair center and they lost the plastic insert. So we have to make a new one. That's pretty easy to do. Let's get started. So the purpose of a plastic insert for a watch, any watch, whether it's quartz or mechanical, is to keep the watch movement from flopping around inside the case. So, these kind of things are important to support the movement within the case so that when you wear the watch, it's not banging around causing other problems. The problem is, like I said, the other repair shop at the flea market lost this plastic insert or didn't put it in. Maybe they just thought, well, it's a cheap Chinese knockoff. It's a piece of junk. We won't do it. Customer really likes this watch, wants this watch working again. And other than the slight repair we have to make to it, we have to figure out how to get a new plastic insert. Now, because they are knockoffs from China, we can't get parts for these. They're just, they're disposable watches. What we have to do is take into consideration all the dimensions inside this, which are these. So we have an outer diameter of 36.7 millimeter, which would be the circumference of the inside of the case. The movement itself is 30.53 millimeters. So I want to design that insert to be a ring that holds it in place with a 30 point, let's say 55 millimeter insert, and maybe a 36 point. I'm going to design this because there's going to be a little shrinkage in the resin when we 3D print this. So I'll make this 36.8 millimeters and a height of 6 millimeters. We also have to take into consideration that the weight wheel or the winding weight has to be free of any contact of the plastic ring insert, so I'm going to compensate a little bit for that. We also have to look at the dimensions of the back cover. When the back cover is screwed onto the case, there is a slight depth that we have to account for. I mean, other than the fact that the case is 6 millimeters deep, we also have to account for this lip on the case where the threads in the gasket are. So if we take a look at that, what we're doing is we're measuring the entire case, and it's approximately 5.15 millimeters, and then just the lip here. I'm going to try to do this as best I can. We have a lip of approximately 1.3 millimeters, which means that when I design this, the plastic insert, if we looked at it from a profile, a side profile, oops, my marker's not working, we have to have this slight insert on the side of this little cutout so that I can screw down the case and have the case hold the plastic movement holder in place. So we're going to accommodate that all in our 3D design. Let's go over to Blender and design this out and then 3D print it on the Epax X1 printer. Okay guys, so I've got Blender all fired up and we're going to start working on our design here. The first thing we have to do is we have to make a cylinder that's going to match the approximate size of the movement holder. So I'm going to do Shift A, and let me go turn on my shortcut key so you can see over here what I'm using. I'm going to come over to Shift A in my 3D panel, and I'm going to add in a cylinder. I'm going to give this cylinder approximately 200 vertices, and then we're going to give it some dimension. I'll come over here and I'm going to make this, just close this down here. I'm going to make this, like I said, the outer diameter of this has to be about 36.8 millimeters, 36.8 millimeters, and we're going to make this approximately 6 millimeters high. So this would be the approximate size of the movement holder. We have to add in a cylinder so we can use it as a cutout to create the inside diameter. So let's do that now. I'm going to hit Shift A. We're going to make another cylinder. I'm going to size this down to the inner diameter of the movement holder, 30.55 millimeters, 30.55, and we're going to make this 7 millimeters because we're going to use it as a cutout. So you can see it protrudes from both the top and the bottom. So with that done, I'm going to select the cutout first and then the movement holder second, and then we'll remove using the Boolean tool in the edit Boolean difference. And now I have the part where the watch will sit and the movement holder will fit into the case. The next thing I want to do is just make an inside cut to accommodate for the winding weight, and I'm going to make that just a little bit larger than the inside diameter of the movement holder. So we're going to add in another cylinder, Shift A, I'm going to come down to Mesh, Cylinder, and we're going to make this one, instead of 30.5, we're going to make this 32 millimeters, and we'll make this 5 millimeters. Now it only has to sit up a little bit, and again this is just to accommodate for the weight wheel so there's no friction. So you can see I'm looking at this from the side perspective. I'm making a cut on the inside parameter of the movement holder. That way I know there will be no friction from the weight wheel spinning. So with the cutout selected, I'll hold the Shift key down, select my movement holder, and then again go to the Edit tab and use Boolean difference. Okay, so you can see that I made the cutout for the weight wheel. I also want to make a cutout for the outer perimeter so that I can have a little bit of space for the back cover when it screws down to hold that in. Remember we said that was about 1.15 millimeters. So we're going to adjust that. We have to make another donut shaped cylinder, so I'm going to hide this. We're going to call this watch holder, and we will hide it, and let's make a new cylinder with a cutout in it. Shift A, and we'll add in a cylinder. We're going to size this down to 37 millimeters, 7 millimeters, and we'll make this 5 millimeters. And now I want to add in another hole onto this, so we can use this as our cutout. Shift A, Mesh, Cylinder. We've added a second one, and we'll make this one, let's say, 34 millimeters by 34 millimeters by 5 millimeters. Okay. I'm going to make that a little bit bigger along the Z-axis, SZ, size it up, and with that selected, we'll select our other cutout, and again, I'm going to use the difference here, so I have this too. I'm going to bring that up, and then we'll unhide our watch holder. Now I need to bring this down a little bit, and I want to get this so that it's approximately 1 millimeter over each of these little boxes in millimeters. So we have 1, 2, 3, 4, 5, 6. So right now I'm down to about 1 millimeter, but I want to make it a little deeper, so I'm going to bring it down to about here. And I need to size this up a little bit, so I'm going to hit, with the cutout selected, Shift or size, and then Shift Z, so I don't size it along the Z axis, but only the X and Y. And I'm going to make that just a little bit wider, right about there. Again, we'll look at it from the side view and the top, and you can see we're cutting out this little area here so that our case cover will screw down on the movement holder and hold it in a nice tight position. I'm going to go back to normal view. With the cutout selected, I'll select the watch holder, and again we'll use difference, and now you can see I have a little indentation on the outer perimeter of the watch holder to accommodate for the case. With that done, now I need to make the holes for the stem and the two buttons on the watch. I'm going to go into top view and we'll center in here. We're going to add in a cube for our cutout. Shift A, mesh, and come down to cube. I'm going to make this cube 5 millimeters by 5 millimeters by 5 millimeters. And now what I want to do is kind of move that up to here. And looking at it from the top, it looks like we're going to make a complete cutout through the entire movement holder, but I don't want it to protrude all the way to the top because this is the top of the movement holder, or where it comes into contact with the case back. And this hole, I'm going to make a hole with this cube to accommodate the stem and the crown coming out of the movement. So I'm going to make this a little bit smaller, and then I'm going to size it along the y-axis, SY, and we'll make it a little longer. When we go back to top view, you can see we're going to make a cutout through the movement holder, but leaving some of the top there so that we have a place for the stem and crown to protrude through. With that done and selected, I'll hold the shift key down, select my movement holder, go back to the edit tab, and use the difference tool under Boolean, and now you see I made a cutout for my stem and crown to protrude through the movement. Let's go back into top view, and now what I want to do is make the two cutouts similar to the one we just did for the push buttons. So I'm going to add another cube, shift A, cube, and we're going to make this cube, let's make this cube 5 millimeters by 7 millimeters by 5 millimeters. And you can see I have a rectangular cube here, and I'm going to use that for my cutout for the two push buttons. To do this and make two that are kind of symmetric on this, I'm going to go into tab mode. I am going to go to the modifiers tool right here with the cube selected, and I'm going to add in a mirror modifier, and we're going to modify this along the x-axis. In edit mode, I am going to move this, and you can see now I have two. One that is mirrored. I'm going to move that up a little bit. I'm going to move it over until I get to about an eyeball's perspective. I'm going to rotate these along the z-axis, so I'll hit RZ, and now I can just rotate these how I want them to be. That looks good. I'm going to cancel that. I'm just going to make this a little wider along the x-axis, SX, and then we'll make them a little wider just to accommodate those buttons. I'm going to rotate on the z-axis again, RZ, and we'll put those into about the proper perspective. And if I look at these, I need to move this over just a little bit more. And down, about there. And that should accommodate for the two push buttons on the watch case. I'm going to go back into object mode, press the tab key, and now I have one object that's mirrored into two, and I'm going to apply that modifier. So hit apply, and now I've got these two cubes, which are actually one object. I can still kind of move them, but I can't manipulate them like I used to. And what I will do now is just cut these out of the movement holder. So with the two cubes selected, hold the shift key down, select your watch holder, and then go to the edit tab, use Boolean difference. So here you see I've created the entire movement holder to fit into the insert of the case that holds the watch in place. With that done, I'm going to go into tab mode, I'm going to select all. I'm going to hold Shift N to adjust my normals and make sure that they're all facing outward. This is done so that we can 3D print this. I'll save this as a file on my desktop in an STL format. File, export, STL. Let's go to my desktop. We'll select Object Selected Only, and we'll call this Movement Holder. And then export to an STL file. With that done, it's time to go into the Sheet 2 box slicer for my Elegoo Mars or my Epax. I'm going to use the Epax printer here. Okay, so with the Sheet 2 box selected, I'm going to import that model. Let's just make this a little wider so it's easier to work with. I'm going to open up that STL file
go to my desktop, and we call that what? Watch holder, movement holder right here. And there it is. I'm going to bring this into Sheet 2 box, just like so. And you can see here's our design, and it's on the build plate just like I want it printed. Now it's time to set the settings for this. I'm not going to use any support materials. I'm just going to allow this to print right onto the print bed. So I'm going to go to settings, select my Elegoo gray resin. On the Epax printer, we're going to do 5mm layer height. I have a bottom count of 5 layers. I'm going to adjust that to 3 layers. I'm going to make this approximately 45 seconds, and I'm going to leave all the other settings just as they are. Under anti-aliasing, I've got a level 2 anti-aliasing. With that done, let me go and explain why I'm only doing 3 bottom layers in 45 seconds. So the reason I'm doing that is because when you print bottom layers at a higher time frame of exposure, what you do is you get a bleed over where the resin that's being cured around the resin that you want cured will actually start to solidify, and it'll give you a pyramid effect into your resin. To accommodate for this, I'm lowering this to 45 seconds and only doing 3 bottom layers. That should be enough to adhere to the bottom build plate for this particular model, and since it is a rather small piece, it should only take about maybe 30-35 minutes to print, and we're going to do the slicing now to see how that comes out. And we have 31 minutes, 51 seconds. So if I adjust this, you can see we should be fine all the way down. I don't need any support for this. It should work perfectly. And I'm going to save this to a memory stick. Okay, let's save this out to my Epax USB card. And I'm going to come down here, Epax. We're going to call this movement holder, and I am going to hit save. And now it's going to write that file out to be printed. I'm going to close this up, and let's go to the 3D printer and start printing this.
Okay guys, I got the memory stick in the Epax printer. I have it all set up with some resin. I'm using the, hang on a second. I am using the Fast Cure. This resin works good for these movement holders, and that's kind of why I used it. And we are going to turn the printer on. It should come up now. Let's go to print. We're going to find movement holder, and there's our movement holder. And now I am going to hit start. And we are off and running. Like I said, this should take about 30 minutes, so we'll check back in 30 minutes and see how well it did. Well, 35 minutes later, and look at what we have. We have a nice movement holder, and we are going to take that off the build plate, clean it up, cure it, and get it ready to go into the watch. Okay guys, so I want to follow up on the watch insert, the movement holder. So after a little bit of tweaking, this is what we end up with. Printed just about perfect. It's going to fit the watch really good. I've filed down some of the edges that were, along the bottom here, and I've made that fit good. Now let's just do a final fit into this movement. That's good. We'll throw the cover back on this. And of course you can tell this is not a real Breitling. Okay, the watch is running. There is no more jiggle inside. These buttons don't serve much of a purpose. They're there for mostly looks, and sadly I can't do anything about it, but the date and time set's perfect. You'll notice that the date is a little off. Those little Chinese gears in there just don't fit perfectly. There's not much I can do about that anymore, and it is what it is. But I wanted to let you know that's how you make an insert with your 3D printer for the watch movement holder. And that is my episode today on practical 3D printing for the jewelry and watch industry. I hope you liked this video, guys. If you did, please give it a thumbs up. If you're not a subscriber, considering subscribing. And if you want to get notified every time I upload a new video, hit that notification bell. Have a good day, guys, and enjoy watching.